Welcome to Crack Defense. So in this video we're going to learn about some concepts based on heat. Let's quickly begin. So first we have temperature. Usually it is calculated in Celsius or either Kelvin or Fahrenheit. Now what are the small relations between Kelvin and Celsius, and we can say Fahrenheit and Celsius. So if you know the Celsius value of anything, then you can do Celsius plus 273 to get the Kelvin value of it. If you know Celsius and again need to calculate Fahrenheit, so we have 9 by 5 C plus 32 to get the Fahrenheit value. Now, what is specific heat? So specific heat is nothing but the amount of heat which is required to raise the temperature of an unit mass of a substance by only 1 degree Celsius. So we can say here as the unit for it would be joules per kilogram per Celsius degree. Now there are three types of thermometer that we need to know. First, Galileo's gas thermometer, so which uses air as its gas. And second, we have laboratory use of thermometer that uses mercury. So the temperature here would vary somewhere between minus 10 degrees centigrade to 110 degrees centigrade. And next we have clinically used thermometer, which again uses mercury itself, but the temperature would vary in different range. So we have 35 degrees centigrade to 42 degrees centigrade. And a small concept that we need to know here is the body temperature. A normal human body temperature would vary somewhere around 70 to 37 degrees centigrade, which is 98.6 Fahrenheit. Now let's just go for understanding three thermal expansions. First, we have coefficient of linear expansion that we call it as alpha, which is basically change in the length of object on heating it. So we have this as alpha. Second, we have superficial expansion, which is denoted by beta, and it is change in area of the object. Now, the third and last option is cubical expansion, which is denoted by gamma, and we have change in volume when applied heat. So what are the relations between these three thermal expansions? So if we need to calculate gamma, we have 3 times the alpha, and if we need to calculate what is beta, we have 2 times of alpha. So that are the relations. Now let's try to understand some basic concepts in heat. First, we have latent heat. It is the amount of heat absorbed by a unit mass of the substance to change its state without changing the temperature. First, we have fusion. So when solid changes to liquid without changing its temperature, we call it as fusion. And when liquid changes to gas, we call it as vaporization. Next concept is saturated vapor pressure. Now whenever the pressure of vapor above the liquid surface, when the vapor is in dynamic equilibrium with the liquid, that is what saturated vapor pressure is. So we have a simple concept that we need to keep in mind is basically saturated vapor pressure will be increasing when the temperature is increased. Now coming to the boiling point. Now what is it? Very simple. When the saturated vapor pressure is equal to the atmospheric pressure, that is where we get the boiling point of any liquid. We can say here that if the pressure around, or you can say the atmospheric pressure, increases, then of course the boiling point is going to increase. That's why wherever we get higher pressure, we just need to wait a little longer to boil for any liquid.